Assalamualaikum warahmatullahi wabarakatuh. May I introduce myself? My name is Muhammad Agam Mutaqin, an actuarial student at Bandung Institute of Technology. Now, I will present a brief explanation of my thesis framework entitled Pure Premium Calculations of Auto Insurance using Spatiotemporal Generalized Gaussian Process Model on Claim Frequency with Taylor Approximation. According to US accident data that occurred in 2015 to 2019, it can be seen that there is a higher tendency for accidents at some locations than others. It's because for different locations, there is a different tendency in terms of vehicle accidents that occur. For example, in densely populated area, accidents tend to be more frequent than in less populated area. In addition, in areas that are more steep and have more sharp turns, the tendency of accidents is also higher. Then, also note in this following graph that there is an increasing trend in the frequency of accidents in US, which is an indication that time can be an important variable in predicting the frequency of accident in the future. With this background, I plan to write a thesis with the following objectives. The first is create a model for the frequency of claims using the Gaussian process by considering the spatial and temporal data. The second is predict the frequency of claims in the future with an efficient method for the computational process. And last is determine pure premium of auto insurance based on the claim frequency model. The model that I use in the thesis based on generalized Gaussian process model framework with three main components, namely random components as the assumptions of claim frequency, which is Poisson distributed, latent functions, which is modeled directly with Gaussian process, and last is link functions, as connected between two previous components. The following is a framework of the data required in this modeling, with locations and time as input variables, and claim rate as response variables. As a result of modeling using Gaussian with Poisson likelihood, an analytical solutions of the predictive distributions cannot be obtained. So, by using Taylor approximations to the likelihood, we can get the equations of the log marginal likelihood and the predictive distributions of F star, as shown on the screen. Furthermore, to obtain the predictive distributions of Y star, an approximations of the log gamma to Gaussians is used, so that the solutions of the predictive distributions can be obtained as a negative binomial distributions with parameters as shown on the screen. So for the last part, we can obtain the expected loss from each month by multiplying the expected severity and expected frequency from our model. And to obtain the pure premium, we use present value of each component of expected loss from each month. So that's all for a brief description of my thesis framework. Here are some references that I have used so far. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.